Eratosthenes lived a long time ago. He was born in 276 BC in Greece. Eratosthenes was a very curious person. He studied many things like poetry, astronomy, and geography. Later, he became the head librarian at the Library of Alexandria in Egypt. This library was like the Google of the ancient world. It had scrolls and books from many different places. Eratosthenes got to read all of them. One day, Eratosthenes read something amazing. It said that in a city called Syene, south of Alexandria, something special happened on the summer solstice. On that day, the sun was directly overhead at noon. This meant that there were no shadows at the bottom of a well. Eratosthenes wondered if this was true in Alexandria too. Back then, many Greeks already believed that the earth was a sphere. Philosophers like Pythagoras and Aristotle had made arguments for this idea. They observed things like the curved shadow of the earth on the moon during a lunar eclipse. They also saw how ships sailing over the horizon seemed to disappear hull first. This wouldn't happen if the earth was flat. Eratosthenes was also convinced the earth was round. He thought about the information from Syene. If the earth was flat, the sun would hit all places at the same angle. There wouldn't be a difference in shadows between Syene and Alexandria. But if the earth was curved, the angle of the sun's rays would be different in different cities. Eratosthenes decided to do an experiment. On the summer solstice, he placed a stick straight up in the ground in Alexandria. He measured the angle of the shadow cast by the stick at noon. Guess what? There was a shadow. This meant the sun was not directly overhead in Alexandria like it was in Syene. Eratosthenes knew that the earth was curved. He also knew that the distance between Syene and Alexandria was about 5,000 stadia, an ancient Greek unit of measurement. By comparing the angle of the shadow in Alexandria to the angle in Syene, which was 0, he could use geometry to figure out the Earth's circumference. Eratosthenes found that the angle of the shadow in Alexandria was about 7.2 degrees. This is about 1/50th of a full circle, which is 360 degrees. This meant that the distance between Alexandria and Syene was about 1/50th of the Earth's total circumference. Since he knew the distance between the cities, he could calculate the Earth's circumference. He multiplied the distance between Alexandria and Syene, which was 5,000 stadia, by 50. This gave him a circumference of about 250,000 stadia. This is very close to the actual circumference of the Earth, which is about 40,000 kilometers. Eratosthenes' experiment was a major scientific achievement. It showed the power of simple observations and geometry. It also gave us a more accurate understanding of the size of our planet. This paved the way for future explorers and scientists to make even more amazing discoveries. Eratosthenes' work was not just a remarkable achievement for his time, but it laid the foundation for future generations of scientists and explorers. His method of using simple observations and geometry to measure the Earth was revolutionary. It demonstrated the power of critical thinking and scientific inquiry. Eratosthenes' legacy lives on, inspiring countless individuals to explore, question, and understand the world around them. His contributions remind us that curiosity and knowledge are timeless pursuits that continue to shape our understanding of the universe. And what do you think is the biggest takeaway from this amazing experience?